So now question 1. Which atom has its outermost electron in an orbital of the shape shown? So which orbital actually it is? The shape shown, that is p orbital, right?
Yes.
And with principal quantum number 3, with principal quantum number means the number of shells, the outermost shell, total 3 shells in it. So it means that should be a member of period 3, right? Because all members of period 3, they have 3 shells in them. So when we say principal quantum number, it means n value is equal to 3.
3.
So second period members, they have 2 shells. First period member, they have 1 shell. So if we look into these, which out of these 3 are in this period 3? So sodium is in it, chlorine is in it, calcium is not in period 3, and bromine is also not in period 3, right? And now
Mm-hmm.
they are saying it has electrons in the p. If we look at the configuration of this sodium, its configuration is 1s2, 2s2, 2p6, and 3s1. And chlorine has configuration neon with 10 electrons, and then 3s2 and 3p5. So outermost orbital or outermost shell of chlorine has a p orbital with electrons, while sodium outermost energy level is third, but s orbital. So they are saying the orbital p has electron. So which option out of these two? That should be
Fine.
chlorine. The another way is also we can look at these two. Sodium is in group 1. So group 1 and group 2, they are called S block elements, isn't it?
Oh, yes.
And while these other group 3, 4, 5, 6, 7, and 8, they are P block elements. It means their p orbital is in a process of filling. So we can also save our time by instead of writing their configuration. So that's how we can get the correct answer. B. Now question number 2. They're saying which atom has the same number of electrons as the hydroxide ion? So let's look at the structure of the hydroxide ion. So first of all, let me draw an oxygen atom. So oxygen atom has 2 electrons in the first shell, right? And then 6 electrons in the second energy level, right? And let me show
Mm-hmm.
these 6 electrons like this. So that is oxygen with 8 electrons. And out of those 6 in the outermost shell, it is using one of its electron to make a covalent bond with hydrogen. So that is now OH, neutral without any charge. But if oxygen gets 1 electron, then it is negatively charged. So I can write it like this: OH and minus 1. Clear? So in this hydroxide ion, how many electrons? There are 2, 4, 6, 8, and 10 electrons. So in options, which one has 10 electrons? Fluorine has 9 electrons, neon has 10 electrons, sodium 11, and magnesium 12. So according to the structure of this hydroxide ion, this neon has same electrons as the hydroxide ion. Is it clear?
Yes.
Okay, now let's look at question number 3. In separate experiments, 5 samples of each of 4 S block elements. They are S block, it means they belongs to either group 1 or group 2. Are added to an excess of water. The gas evolved is collected and its volume measured under the same conditions. So these are the metals and they are basically added to the water. So for example, if I have calcium, so when I add calcium in water, what will be the product? Calcium hydroxide and hydrogen gas.
Hydrogen.
Okay, they are saying 5 gram sample of each of them. So if I have 5 grams of calcium, so how many moles of calcium I am actually using? So 5 over molar mass of calcium, it's 40. So answer is 0.125 moles. So according to this equation, 0.125 mole of calcium will produce 0.125 moles of hydrogen because the ratio is 1:1, isn't it? So it means it will
Mm-hmm.
produce 0.125 moles of H2.
Hydrogen gas.
Similarly, I can look at potassium. When it reacts with water, it gives us potassium hydroxide and H2 gas. But now, in this case, to balance this equation, I can write 2 and 2 potassium hydroxide and 2 with the water as well. So here I have a ratio between potassium and hydrogen 2:1. So let's find out first of all moles of potassium because they have given the 5 grams of each of them. So 5 over molar mass of potassium, it's around 39. So if we divide it, it gives us 0.128 moles.
8.
So it will produce how many moles of hydrogen? 2:1. So half of it.
Mm-hmm.
So it will be 0.128 divided by 2. That gives us 0.064 moles of H2. And
8.
similarly, rubidium. Rubidium is also in group 1. So if it is in group 1, it will give the same balanced equation like potassium,
Mm-hmm.
rubidium hydroxide, and H2. So let's find out the moles of rubidium. So 5 over its molar mass, it's 86, right? So 0.0581, they will produce half of it because 2:1. So it's 0.0291 moles of
H2.
H2. And similarly, we can check for strontium. It is in group 2, so it's balanced equation just like calcium, right?
Mm-hmm.
Strontium hydroxide plus H2. So 5 grams divided by its molar mass, which is in the periodic table, 88, and it gives 0.057 moles. So same number of moles because 1:1, right?
Yes.
So we know that that number of moles multiplied by volume, 24 dm cube is the volume of a gas. So it means the one which have greater number of moles will have greater volume. So in which option we can see the greater moles are produced. So that is option A,
A.
because this will have the largest volume of a gas which is produced, right?
Mm-hmm.
Okay, now let's see another question, question number 4. They are saying a student reacts 1 mole of copper with concentrated nitric acid to produce 1 mole of copper to nitrate, 2 mole of water, and a substance X, no other product. So let's see if we have this reaction. So copper reacting with nitric acid, concentrated nitric acid, right? And giving us copper 2 nitrate, 1 mole. And they have given this information as well. 1 mole of copper with concentrated nitric acid and giving us 1 mole of copper nitrate, right? And
Mm-hmm.
2 mole of water, okay, 2 moles of water. And another substance. So another substance options, they are either nitrogen only or nitrogen oxide or nitrogen N2O, NO, and NO2. So this could be either NNO. Hmm? No other products, right? Substance X does not contain copper or hydrogen. So this could be either out of these 4. So how can we check that which substance? So by balancing equation. So first of all, how many nitrates are on the right side? We have 2 nitrates. Copper is balanced. What about nitrogen? Is it balanced? No.
No.
And hydrogen, there is
Not
one.
ones.
There are 4 hydrogen atoms. So to balance it, let's make it 4 hydrogen, right? So by
Mm-hmm.
balancing this, we have 4 hydrogen atoms. So now what about nitrogens? There are 2 here, and I have written 1 here, right?
Mm-hmm.
Okay. And what about oxygen? So here we need 2 nitrogens. So we can have either option this or this or this or this as well because nitrogen atoms. But let's look at the oxygen atoms. So how many oxygens are there? 12 here. 4 3s are 12. How many oxygens are there? 3 2s 6 here, right? And we have 2 here. So it means there are oxygen atoms remaining in this compound X. How many? 4, right?
Yes.
And how many nitrogens? 2. Clear? So the simplest
Yes.
ratio between this nitrogen and oxygen can be 1:2. So we have only one option in which we have this ratio between nitrogen and oxygen, and that is
Mm.
option D, right?
Yeah.
Okay, now another question. Let's see this one. They are saying in which 3 structures 3 atoms bonded together in a straight line. Okay, so let's see first of all polyethylene. So CH2, right? And CH2. Can you tell me the type of hybridization of this carbon? It is making 4 single bonds. So hybridization is
sp3.
sp3. And whenever sp3 hybridization, it has a shape
Tetrahedral.
tetrahedral. And in case of tetrahedral, none of the atom is in a straight line. Straight line means 1, 2, and 3 in a straight line, making angle simple, straight 180. So none of them is, this carbon is also sp3 hybridized. So tetrahedral. So the angles are 109. Clear? So
Yes.
same will be the case in case of propane. We have seen that propane, C, C, and C, all of them are sp3 hybridized. So it means none of them is in a straight line. Now, SiCl4, so its structure is again tetrahedral structure. Hmm?
Mhm.
Okay. But what about this sulfur hexafluoride? So if we look into this sulfur hexafluoride structure, it is octahedral structure. Octahedral structure means sulfur is in the center. You can imagine a table in front of you. There are 4 corners of that table, right?
Okay.
Here is fluorine, here on the 4 corners of the table. And this sulfur is present on the surface, center of this table. So if we will look at this, what's the angle between these two? 90, and these two, 90. So we can see that fluorine, sulfur, and fluorine, they are in a straight line. These 3 atoms. Similarly, these 3 atoms, they are in a straight line. Clear? Okay. And what about the other 2 fluorine atoms? So one above the surface and one below the surface. So this is actually octahedral structure. And in octahedral structure, all angles are, you can see, 90 degrees. So these atoms, they are in a straight line. So that means option D is the correct answer. Is it clear?
Yeah.
Okay, now let's see another question. Question number 6. Which statement about aluminium chloride is correct? Remember aluminium chloride, the bonding in case of aluminium chloride. And we also discussed that aluminium chloride in vapor state exists as a dimer. Dimer means there are 2 aluminium chloride molecules which are linked together by a dative bond. So Cl, Al, and Cl, and Cl. This chlorine is making dative bond with this aluminium, right? And this chlorine, that is the structure of Al2, Cl6.
Mhm.
Okay, let's see the options now. They are saying aluminum chloride has a much higher melting point than magnesium chloride due to the small size of the aluminium ion. So what do you think? Here we are seeing when we move from left to right in a period, the type of bonding that shifts from ionic towards covalent. So the bonding in case of magnesium chloride. That is more ionic as compared to aluminum chloride. Why? Because electronegativity difference that is greater in case of magnesium chloride as compared to aluminum chloride, isn't it?
Yes.
So if electronegativity difference is greater, then there will be more ionic character, and more ionic character means strong forces. And if strong forces, then it will have higher melting and boiling point. So they are saying much higher. No, that's incorrect, right? Option B, they are saying anhydrous aluminum chloride reacts vigorously with water to form a solution with a pH greater than 7. So we saw in the reactions of aluminum chloride with water. So that gives us HCl, an acidic product. So it means it will be an acidic solution if aluminum chloride reacts with water. So the pH should be less than 7. No. And C, Al2Cl6 molecule found in aluminum chloride vapor contains two coordinate bonds. Yes, it contains two coordinate bonds. So option C seems correct. So what about D? The bonding between aluminium and chlorine is strongly ionic. No, we are saying that is a covalent due to the large difference in electronegativity. It's not strongly ionic, it's partially ionic. Here, so not strongly ionic, it's partially
Ionic.
ionic. Because when we move from left to
So,
right, yes,
could you explain why B is wrong again?
D,
B.
yes. So they are saying the bonding between aluminum chloride is strongly ionic. So remember when we move from left to right, the
Oh, it seems like B.
electronegativity, sorry,
The option B,
this one,
the second one.
yes.
Yeah.
They're saying anhydrous aluminum chloride. So look at this. If you look at the reaction of aluminum chloride with water, so it gives us HCl and will give us aluminum hydroxide.
Oh, okay.
That is strong acid. So due to this,
Okay.
the pH should be less
Should be
than
less.
7.
Okay.
Okay, now next question number 7, that is again with the calculation part. Now in this, you can see what they have given and what they are asking about it. Let's do. They are saying potassium nitrate reacts with carbon and sulfur solid and giving us carbon dioxide gas, carbon monoxide gas, and nitrogen gas, right? And the other products, these are solids. Here, a sealed tube containing black powder. This is the black powder, potassium nitrate, right? Has a volume of 10 cm cube. Okay, so they have given us the volume of the container, which is 10 cm cube. When all of the black powder reacts, the reaction causes a pressure. So they have given us a pressure, which is 2 into 10 raised to power 6 pascals, right? and a temperature of 2500 Kelvin. That temperature is given. They are saying the volume of potassium carbonate and potassium sulfide produced can be ignored. Okay, they are saying ignore them. Only consider the volume of these things or the gases, right? That is the volume of these gases after the reaction. So now they are saying how many moles of potassium nitrate are produced in the sealed tube. So they are asking about the moles of this potassium nitrate. So we can calculate the moles of potassium nitrate if we are able to find the moles of these gases. So how can we calculate the moles of these gases from this given data? Remember, we have general gas equation PV is equal to
N3.
NR. So N is the number of moles, right? So
Mm-hmm.
we have pressure, we have volume, we have temperature, and R is constant. So if I rearrange it, I can calculate the number of moles. So N is equal to PV over RT, right? So now
Mm-hmm.
here, before putting their values, so the units must be same. Remember that R value, that is 8.31. And during the calculation of this R value, which is joules per Kelvin per mole. And in the calculation of this value, we used the volume in cubic meter. So I have to convert this volume 10 cm cube into cubic meter. And for that, I know that this cm cube and cubic meter relationship, which one is greater? This one is the bigger value. How many times? We know that 1 cubic meter is equal to 1000 dm cube. And 1 dm cube is equal to 1000
C.
cm cube. So it means cubic meter is how many times greater than cm cube? That is 1000 into 1000 times, right? So if I want to
Yes.
convert it into cubic meter, I have to divide it by 10 raised to power 6. So by doing that, it will be 10 into 10 raised to power minus 6 cubic meter, right?
Yes.
Now let's put these values here. So it is already, pressure is in Pascal. So 2 into 10 raised to power 6 multiplied by volume, which is 10 into 10 raised to power minus 6 over R 8.31 and temperature is 2500. So if we calculate, we will get the value of N, right? Do you have a calculator?
Yes. Yeah.
Okay, so let's use it. Okay, to save our time, its answer will be hmm,
B.
no, we'll get the answer which will be 9.63 10 raised to power minus 4. That is the value of N. Now, after this, actually, these are the moles of all these gases. right? So
All
here,
right.
what's the relationship between the solid potassium nitrate and gases? So I can say that potassium nitrate and gases relationship, moles ratio, 3 and 2, 3, 6 and 2, 8 moles of gases are produced from 4 moles of potassium nitrate, right?
Mm.
So if these are the moles of gases, 9.63, 10 raised to power minus 4. So how many moles of potassium nitrate have been used? So half of it, isn't it?
Yeah.
So the option A, is it
Mm.
clear? Okay, let's see another question. This one, question number 8. They are saying for which pair is the boiling point of the first compound higher than the boiling point of the second compound? Actually, boiling point, that depends on which thing? That depends on intermolecular forces, right?
Yeah.
So the one with stronger intermolecular forces will have higher,
Higher. Mm-hmm.
yes, boiling point. Okay. So let's see option A. In case of option A, we have an alcohol, right? So CH3, CH2, and OH. Now this OH group, actually, that is responsible of hydrogen bonding. It can make hydrogen bond with another alcohol molecule, isn't it?
Yes.
So hydrogen bond is stronger intermolecular force as compared to simple attractive forces. So it means that this one have higher or stronger uh, intermolecular force than this one. So sulfur is also present in group 6, right? Oxygen
Mm-hmm.
and then sulfur. Which one have less electronegativity? Definitely sulfur,
Mm-hmm.
right? So it means if we have this bond like this, so here due to less electronegativity, so sulfur is less negative. Electronegativity difference is smaller here as compared to OH group, right?
Yes.
So it means in this case, the attractive force will be weaker as compared to this ethanol, right? So lower boiling point. They are saying
Mm-hmm.
first member have higher. What about second member? It's CH3, C double bond ester, CH3, C double bond O, and then CH3, right? This one. So no hydrogen bonding. While the second option, this one is an acid, right? C double bond O and H. Here it has OH. It means it can make a hydrogen bonding. So second member will have higher boiling point than the first
Mm-hmm.
member, right?
Mm-hmm. Yes.
Here it has OH group hydrogen bonding, and here it's an ether,
Here it's a
CH3O and CH3. So no hydrogen bonding in this case as well. So lower boiling point than second one. And what about this one?
Mhm.
It's an aldehyde and it is an acid. So aldehyde also have this group, C double bond O and H. So no hydrogen bonding. And here it can make hydrogen bonding because of OH group. So higher melting point than the first one. So option A
A.
is correct, right?